I would say three significant figures for 8, because molality is 3 sig figs, your freezing point constant is 3 sig figs, and then your Van Hoff factor is kind of it's a known, right? It's a given number, so that's infinite number of significant figures. So because of that, I would say 3 significant figures for everything involved. All right, my favorite question, question 12. We've got a bottle of wine. It's 12% volume by volume. We want to know all these things about it. We want to know the Van Hoff factor, moles, molality, and then ultimately the freezing point of that. So we're going to start with its 12% wine, volume by volume, which means in that 1.5 liter bottle, right, 1,500 milliliter bottle, 12% of it is ethanol. The remaining would be water. So 12% of 1,500 milliliters is 180 milliliters of ethanol, which means I've got 1,320 milliliters of water. So ethanol is a molecular compound. Its Van Hoff factor is 1. I can use the density to find moles, right? 180 milliliters, they tell me it's 0.789 grams per milliliter. So I've got 142 grams of ethanol in that bottle of wine. Ethanol is about 46 grams per mole. So I divide that to get about 3.09 moles of ethanol. Molality, we found moles. Molality is moles over kilogram solvent. So I had 1,320 milliliters of water. I know the density of water is 1 gram per 1 milliliter. So I've got 1,320 grams of water, which is 1.32 kilograms of water as my solvent. So find the molality, 3.09 moles of ethanol divided by 1.32 kilograms of the solvent. This solution is 2.34 molal. Many of you are using the total solution when you're trying to find molality, right? And that's not correct. We want to just find molality using just the solvent, right? Molarity uses the total volume of the solution. So there is our third question. And then our fourth question, what would the freezing point be, right? Change in freezing point equals our Van Hoff factor, freezing point constant times molality, right? Van Hoff factor is 1, freezing point constant at 1.86 degrees Celsius per molal, because again, it's an aqueous solution. That's the freezing point constant for water, times our molality. I get a change in freezing point of like minus 4.35 degrees Celsius, which our normal freezing point for water is 0. So I subtract that from 0, right? My final freezing point for this solution is going to be negative 4.35 for question 12. All right. Question 13 is very similar, and the same problems that were kind of coming up on Friday were that people were not taking into account that molality is just the mass of the solvent and not the total mass of the solution or the volume of the solution. So for question 13, they tell us, right, the average ocean water contains 34.2 grams of sodium chloride per 1 liter. So in 1 liter of water, there's 32 grams of sodium chloride. My one issue with this question is they should have told us the density of salt water. Salt water is more dense than water, regular water. So one step here is a little bit, we're making an assumption that's not correct. We got to find moles, molality, and then the boiling point of this solution. So Moles is pretty easy because they told us, okay, 34.2 grams of sodium chloride. Sodium chloride is 58.45 grams per mole. So I've got 0.585 moles of sodium chloride. Many people are putting this same answer for the molality. They're saying it's the exact same thing. It is not the exact same thing because molality is moles per kilogram of solvent only, not the total solution. All right, I've got 1 liter of solution. And here's where I'm making an assumption that the density of this is the same as water. We know it's not. Salt water should be more dense, but whatever. 1 liter is 1,000 milliliters, which would be 1 gram per milliliter, the density of water. 1,000 gram solution, full solution. Subtract my 34 grams of water or my sodium chloride, leaving about 965.8 grams of solvent, just the water. Right, I can turn that into kilograms and divide by 1,000. So my molality would be 0.585 moles of sodium chloride divided by 0.9658 kilograms of solvent. Right, and now you can see those two numbers aren't the same. For everyone that tried to answer both steps with the same number, they are not the same. This solution is 0.605 molal. Now I can find the change in boiling point, right? Boiling point, change in boiling point equals my Van Hoff factor times my boiling point constant times my molality. Van Hoff factor for sodium chloride is 2. It ionizes and gives me 2 things. Times 0.52 degrees Celsius per mole. That's my boiling point constant for water. Again, that's a constant. This is for any aqueous solution. The molality that I just found out, 0.605, to see that my change in boiling point is 0.63, which my initial boiling point was 100 because it's water. So like 100.6. This question asks you to answer it to 3 significant figures. So yeah, let's just round that 100.6 to 101 degrees Celsius for question 13.